Hello everybody, my name is Professor Marcelo Marotta. I will present today PyDASH, which is a framework-based educational tool for adaptive streaming video briefing study. With me on this work is our student Gustavo Cisosa, Professor Maristela Holanda, and Professor Marcos Caetano, and we are all with the Department of Computer Science of the University of Brasilia. To speak a little bit about this work, I will do a brief introduction of it, what are our proposal, our prototype, results, and then finally our final remarks. Starting by the introduction, the educational system faced a very challenging scenario with the COVID-19 pandemics. We could not have any physical activities, no access to universities and physical facilities, only remote classes were available to work with the students, and pretty much everything that we could work presentially could not be used anymore. This is a very challenging scenario to everyone and in every educational institution, but for us from the Computer Network Society it's even more challenging because pretty much our classes are done with very specific equipment, and because of those very specific equipment, they cost a lot. So we could not ask the students to buy it. We could not ask the university to lend these equipments to students. So we're facing a big challenge to do our classes to our students without requiring those equipments. So what we have to do, we had to find a use case from from the computer network area to allow the students to do remote classes and still work with the network environments. For that, also the pandemics bring a different type of problem to the network. According to the Cisco annual forecast report, around 15 to 30% increase of the internet traffic were caused by, among other reasons, educational video streaming traffic. So a lot of professors were doing their classes completely remote, so using video streaming to give those classes. And also some another foreseen from this annual forecast that in 2021 it was expected that almost 82% of all internet traffic will be video related. In these scenarios, we have a tremendous impact on the internet because we have our internet having their capacity completely used by an application completely based on video. And this was a perfect use case, a study case for our students to work on their own home to get a network scenario to work with. But for that, we have to take a look on how to solve this tremendous impact on the internet. And one way to do it is to use optimized video stream solutions such as Dash. And before I explain how the students could use Dash for working on this use case in this very challenging educational scenario, first I have to explain how Dash works. Dash is pretty much dynamic adaptive streaming, and it will work over hypertext transfer protocol, and pretty much it works on top of a client-server architecture, where the client will do some video requests to the Dash Video web server, and the Dash Video web server, for instance, will give back the video. But because Dash allows to dynamic adapt the way the client will consume this video, instead of just give an entire string of bits that is a very huge quantity of bits from a video, it will actually make some partition on the video, and will turn it into different segments, and those fixed segments will have a fixed time slot with a fixed encoding. And what happens with those encoding? This encoding will be done to give some quality to the segment. So the higher the quality, the best quality experience of the user, but also the higher the quality, the larger will be the segment to send through the network. So if the network is facing any capacity issues or something that will be related to that compromise their sending of the segment, the user may not receive those segments and also have freezing on their video that will be even worse. They have a bad QoE, that's a bad quality of experience. It can be even drastically bad for the user. So the challenge here is to have some video with the best quality possible without freezes. But this will be very challenging to do. So you have to get the status of the network, deal with it, and try to figure out which is the segment it's best for the occasion to be downloaded and also to be buffered on the side of the client. This will be using some APR solution that will be some algorithm that will be adaptive bandwidth rate such that it can download the correct segment and then use those segments to be bufferized and then played by the client. And how it will work. Our proposal is based on Dash, so we use HTTP protocol to communicate with HTTP server. And our implementation of Dash will be based on the Python language. That's a very high level language. And it will allow the students to use it without so many problems. And by consuming some MPT files that are like a list of what are the available segments from the web server, the client can determine based on their own network condition which is the best segment to be downloaded. Considering this, on the Dash client, we implemented the player that will be a module that will be able to be playing the video and then will be buffering also the segments. The IR2A, that is another plane that will have like the ABR algorithms, that is the logic behind the determination, the way you determine if you will get some segment with some quality or not on that period. And the connection handler that will get the status of the network and feed the IR2A to use those information to get to download the next segment and which is the quality of the next segment. The flow is pretty much an MPT request from the Dash client that receive an MPT response. That's the list of all the segments available and all the qualities. And then the IR2A starts to ask through HTTP requests the next segments that we will have to consume, such that the player can start to play those segments to the user. How we prototyped that? According to our interest, if we just give an implementation of PyDash like that we are using there, our students would have to develop their own R2A algorithm, which is like an ABR algorithm, but it will not be a very challenging scenario because what are the requirements to use this prototype? The user, or in the case our students, will have to have their computer, that's a notebook or desktop, doesn't matter, that will have their network card connected to some internet link. But if you use just the internet link, we'll have some issues regarding how rich is the network environment. Because if we take a look on that, they will have just the capacity lease from some operator. What we want a more richer network scenario so that they can use it to get some concepts that from our classes from there and so on. So how we do that? We use different simulators like NS3 and ONNET that will be embedded together with our code. And using PyDash, they will be having those simulators creating a more richer network environment that will be placed intermediary between the PyDash client and the network card exited to the internet. By doing that, we can manipulate how the network will be behaving, how many devices are in the middle, how many, how are the characteristics of the network, if they have like less capacity, more capacity. And because of that, we implemented PyDash on top of that, and then our students could have their ABR solution be placed there. And with this richer network environment, they could have some response from their experiment, given their execution time, how much was the buffer size during the execution, how much segments were there, how the segments were consumed during the experiment, and so on. And based on that, they could control the whole experiment and take a look of how their logics of getting the next segment or not is performing and if it's good for the application or not. And this will give them a good way to interpret the network status. And also they can use like Wireshark, like there's a network tool that will be sniffing the network, the simulated network or their network card, and they can get the packets, where the packet went, where the packet come, from where the packet come, what are the headers of the packet, that are very important concept from network courses, and then we can have all of this experimentally based on the PyDash educational environment. Also, PyDash gives a lot of different plots that can be used to the students to get to know how their ABR solution is working. Just to have a glance in that, like the throughput of the network, the simulated throughput of the network. So if they range like from 0 to 8 megabits per second, and then how it was behaving, and also if they have good capacity or bad capacity, and what happened to the playback QI history. They have like good quality of segments being downloaded, or if not, then all of those plots can help the students to get a glance on how their experiments going on. Also, by considering all of this prototype, we do some evaluation methodology. PyDash primary purpose is to deploy flexible educational tool. So our evaluation scenario is pretty much based on 3 courses of computer network science, from computer network courses, and it's all about their final assignments. And we had about 120 undergraduate students that were divided into groups of 3 students each. And those groups will have their first contact with ABR protocols and the concept of PyDash tool to have a rich network environment and to use as a use case for remote activities. Of course, we give some material to them to implement their own ABR. We had a lot of articles that are from the literature that they could use to implement their own solution, but also the students propose different uses and different articles to implement their own solution. And based on that, they could explore this new articles, new papers to get their own ABR solutions. The evaluation methodology. We have like a lot of supportive material to the students. We give a video class explaining what is an ABR protocol and why they are important. We also give a video class explaining an example of how to code a very simple ABR protocol in PyDASH and how they would work with the framework. We also give source code with different implementations of the ABRs to use the PyDASH and some documentation about the PyDASH architecture. Regarding our results, it's pretty much based on how successful the platform was to give some concepts about network to the students. So what we did, we measure how many of the students passed on the classes, and about 89% of our voluntary students passed on the classes, just 5% of them failed the classes, and just 6% of all students dropped it due to their own reasons. Regarding their solutions, we divided the solutions according to their complexity to be implemented, and although the vast majority of the students try to use from very simple to simple solutions, like about 71% of them, there was about 30% of the students that tried to challenge themselves and to use very complex solutions with high complexity. It was really interesting to see the students giving a great effort to try to deal with those scenarios. We also give some scenarios that were more challenging, like what happened with the internet capacity varying a lot, or scenarios that will have like low capacity, scenarios with good capacity that suddenly drops and then fall. We all have this kind of scenarios being placed in there to test their ABR solutions. Finally, the grades were scored also and clustered according to the complexity of your solutions implemented. Since I say that there were 3 classes, we separated 3 classes here, and pretty much all the students with the best grades tried more complex solutions, but also they could arrive at good grades also by implementing some simple ones. Our final remarks. PyDash is a great educational framework for network courses. We could use it not just to implement APR algorithms, we could also use it to get some packets from the network, do some sniffing on the network, get some routing perspective of the packets, reading their headers. So it's not a tool just for APR, but also a complete tool that allows to create richer environments for the students to work on network classes. Thank you very much. Bye-bye.